Hey everyone, welcome back. Electric vehicles versus gas vehicles. What are the cars made out of? Today we've got a really interesting video to make. This is a look beneath the actual cars that we've got on our roads and the material that make up those cars. What's the difference between gas cars and electric cars? So electric vehicles require a wider range of minerals for their motors and battery compared to gas cars. That's the first thing to know. In fact, an EV can have 6 times more minerals than a gas car and be on average 340 kilograms heavier than a gas car. Many EV motors use magnetic materials, typically made with rare earth materials. And this is just calculated as rare earth. On average, it's roughly around 0.5 kilogram of rare earth material that is used in electric vehicles. We've got mineral components. EVs can contain more than a mile of copper wiring inside the stator to convert electric energy into mechanical energy. So in a regular gas car, on average, it's around 22.3 kilogram. In an electric car, it's roughly around 53.2 kilogram of copper that is used in an electric car. That's fascinating. Now, how about graphite? Graphite, it's roughly around 66.3 kilograms that are used in an electric car. And graphites are not typically used in gas cars. Now, graphite is the anode material in the lithium-ion battery and is the single largest component by weight. That's so fascinating. Graphite is quite crucial to an electric car manufacturing. Now, graphite comes in at first because electric cars usually use a lot of graphite. That comes in at number 1. Second on that list is copper. Third on the list is nickel. 39.9 kilograms of nickel are typically used in electric vehicles. That's so fascinating. That's a lot, by the way. That's almost 40 grams. That's a lot, by the way. That's almost 40 kilograms of nickel that are used typically in electric vehicles. Next up on this list is number 4, magnesium. In a typical gas car, it's roughly around 11.2 kilograms of magnesium that are used in regular gas cars. However, in EV cars, it's more than twice that amount. It comes around at 24.5 kilogram of magnesium that are used in typical EV vehicles. In number 5, we've got cobalt. Cobalts are crucial for electric vehicles, and it's roughly around 13.3 kilograms of cobalt that are used in electric vehicles, and they're not typically used in gas vehicles, unless it's a hybrid, for instance. But this video is not about hybrid. It's simply about electric vehicle versus gas vehicle and the material that they use. Next on this list is lithium. That is crucial to every electric car, and lithium is not used in gas car. On average, it's roughly around 8.9 kilogram of lithium that are used in electric vehicles, and they're not used in gas cars. So you can clearly see that electric vehicles, they use a lot more material from the earth. The problem with gas car is just the fuel. The fuel that emits CO2. That's the main reason we're moving away from gas car. Apart from that, gas cars are actually quite efficient, and this video is going to prove that. Now, rare earth material, 0.5 kilograms. Zinc is also an important material in electric vehicles and in regular gas vehicles. On an average, it's just about the same that are used in every vehicle, just around 0.1 kilogram of zinc that are used. And as for other material, this could be a wide range of material from the earth. It's on average for all cars, not just gas cars, but also EV cars. It's quite equal, around 0.3 kilograms on both EV and gas cars. Now this information, this data was from the International Energy Agency, compared to the mineral used in a typical electric vehicle with a conventional gas car. Now, as for steel and aluminum, they're not shown in this analysis. Mineral values are the entire vehicle, including battery and motor. So for one, batteries are heavy. That's an important thing to understand. Batteries are ridiculously heavy. The sale of electric vehicles are booming, and the rising demand for mineral used in an EV is already posing a challenge for the mining industry to keep up with. That's because unlike gas cars that run on an internal combustion engine, EVs rely on huge mineral-intensive batteries to power the car. For example, the average 60 kilowatts per hour battery pack, the same size that are used in Chevy Bolt, alone this contains roughly 185 kilograms of minerals, or about 10 times as much as are in a typical car battery, 18 kilograms that are typically in a car battery in a normal combustion engine car. However, in an electric car, it's 185 kilograms of minerals, Wow, that's quite insane. Now, lithium, nickel, cobalt, magnesium, and graphites are all crucial for battery performance, longevity, and energy density. Furthermore, EVs can contain more than a mile of copper wiring inside the stator to convert electric energy into mechanical energy. So out of the 8 minerals in the list, 5 are not used in conventional car, that are graphite, nickel, cobalt, lithium, and rare earth. So minerals listed for the electric cars are based on the International Energy Agency analysis using a 75 kilos per hour battery pack. That's with a NMC 622 cathode and graphite base anode. So since graphite is the primary anode material that are for electric batteries, it's also the largest component by weight. Although material like nickel, magnesium, cobalt, and lithium are smaller components individually, together they make up cathode, which plays a critical role in determining EV performance. Although the engine in conventional cars is heavier compared to EV, it requires fewer minerals. Engine components are usually made up of iron alloys, such as structural steel, stainless steel, iron-based sintered metal, as well as cast iron or aluminum alloyed parts. So EV motors, however, often relies on prominent magnets made of rare earth and can contain up to a mile of copper wiring. That's just insane. So how is EV huge demand is impacting the metal market and the mining market? The growth of EV market is not only beginning to have a noticeable impact on the automotive industry, but the metal market as well. EVs and battery storage have already displaced consumer electrics to become the largest consumer of lithium and are set to take over from the stainless steel industry as the largest end user nickel by 2040. Now in the second half of 2021, 84,000 tons of nickel were deployed onto the road globally in batteries of all newly sold passenger EV combined, 59% more than in 2020's second half. Moreover, another 107,000 tons of lithium carbonate equivalent were deployed globally in new EV batteries, an 88% increase year over year. So if there's one thing that I can tell you, is that the mining industry will be booming for the next 100 years to 200 years, primarily because of EV companies and how rapidly we're ramping them up. But the demand, we need supply, it's all going to get quite crazy. But for the next 10 to 20 years, it's going to be a crucial time for a lot of investors to invest early into these companies. So that's it for this video. There's other videos that we can make in the future, all about electric vehicles and everything you probably didn't know that takes to build electric vehicles. This video should be important for all electric companies. Polestar, NIO, Tesla, VW, Aldi, all the top EV companies. It should be an important video because they use a lot of minerals and important rare earth materials for these vehicles. Recycling should be a main priority in building and deconstructing these vehicles for the future, if we want to stay as sustainable as possible, which is going to be quite difficult. But I do hope you've enjoyed this video. Thank you for watching. Subscribe to see more. Leave a like, leave a comment, and of course, I will see you in my next video.